Welcome back. We have been looking at graphing quadratics that are in vertex form. Today we're going to switch to graphing quadratics when they're in standard form. So in our picture here, we have the graph of f of x equals ax squared plus bx plus c, where a is not equal to 0, is a parabola. This is standard form. Okay, that's standard form for a parabola. What we had the last few days, having it in that transformation format, is considered vertex form, since HK creates your vertex. Okay, but we're going to work today on ones that are in standard form. The same thing with A happens in standard form as it did when it was in vertex form. So if A is positive, it's going to open upward. And if A is negative, it's going to open downward. Okay? Now we have a formula to help us figure out our vertex and our axis of symmetry. Do you remember yesterday when we talked about a vertex? If our vertex was at, say, the point 2,5, our axis of symmetry went right through that x coordinate, so we had x equals 2. So you'll notice here that our axis of symmetry and the value for our vertex, our x coordinate of our vertex, is the same. So we can find that by taking the opposite of b and dividing it by 2a. That's going to be critical to what we're doing today. Once we know what x is, we can plug it into our equation to figure out our y value. The other thing that's important when we're graphing in standard form, we want to be able to find as many points as easily as possible. So this is how we're going to help find the vertex, which is critical to graphing a parabola. We have to know where it makes that turn. But the other easy point to graph is the point 0c, the y-intercept. Because if I plug zeros in for all of my x's, I'm just going to get what I have left for c. All right, let's go through this with an example. We want to graph the parabola y equals x squared plus 2x minus 3. It is in standard form. So the first thing I have to do is figure out what are these a, b's, and c's. Well, a is the number that's in front of x squared, and since we don't see 1, it's implied that that's a 1. B is the number in front of our x coordinate, so a positive 2. And c is our constant, the piece that doesn't have the x, so negative 3. Notice I'm taking signs with the numbers. Then we're going to use the equation x equals the opposite of b divided by 2a to help us figure out the x coordinate of our vertex. So x equals the opposite of b. So we need the opposite of 2, which would be negative 2. And we're going to divide by the product of 2 times our a value. Well, 2 times 1 is just 2, so this is negative 2 divided by 2, or negative 1. Once we know that x value, we can plug it into our original equation to find the y coordinate that goes with it. So already we know that the x coordinate of my vertex is negative 1. But now I'm going to plug that value back into my equation. So y equals a negative 1 squared for x squared plus 2 times the negative 1 for 2x minus the 3. Squaring a negative 1 means negative 1 times negative 1, which is positive 1. We are adding to that 2 times negative 1, or negative 2, and then subtracting 3. So 1 plus a negative 2 is negative 1, minus 3 more puts us at negative 4. So the y-coordinate of my vertex is going to be negative 4. So let's go ahead and plot that. We want a vertex at negative 1, negative 4. Now the axis of symmetry, remember, goes right through the vertex. So we already know what that is. We can draw a line right through that vertex, and we know that it has the equation x equals whatever our x coordinate was, so negative 1. Our next piece is to find and plot the y-intercept. The y-intercept is always going to be that value 0c. So if I put 0 into my equation, I should get my c value, which we said was -3. So let's plot that point. 0, -3. Now we have 2 points on our parabola. We need more than that to get the nice curve. But what we can do, because parabolas are symmetric, we have that line of symmetry, we can mirror our points across it. So this point that I just plotted here at 0, -3 is one space to the right of my line of symmetry. So I just need to mirror it over and go one space to the left. So now I have 3 points on my parabola. We're going to find one more point and then mirror it over the line of symmetry. So right now we know that the vertex was at -1, -4. My y-intercept is 0c, which in this case was -3. And then let's find one more point. We have a -1 for x, a 0 for x. Let's go ahead and use a 1. So we are going to plug a 1 in for y. And our equation, let's go back up here a sec. Our equation was y equals x squared plus 2x minus 3. So y equals x squared plus 2x minus 3. And we're going to plug a 1 in this time for our x value. So 1 squared is 1. 2 times 1 is 2. 1 plus 2 is 3. Minus 3 is 0. So I can also plot the point 1, 0. That's another point that's on my graph. All right, so let me scroll up here. And we're going to plot the point 1, 0. Now notice that this point is 2 spaces from my line of symmetry. So when I mirror it across, I have to go 2 spaces on the other side. And now I have 5 nice points that are showing me a parabola here, and I can just connect them with my nice curve. All right, and then we also typically found some other information about our graph, like domain, range, max, and min. Domain, it's still a parabola, so x equals all reals. My parabola opens up, so I have a minimum value, and my lowest that I get on my graph is going to be at -4. My range is connected to that number, so I know it's going to be a y with a -4, and I just have to decide, is it greater than or less than that? Since my graph is opening up, I'm moving above that, so I want greater than or equal to -4. Our equation is y equals 2x squared minus 8x plus 1. We need to identify a, b, and c. In this case, a is the number in front of x squared, which would be a 2. B is the number in front of x, so that's -8, and c is our constant of 1. To find our vertex, we said x equals the opposite of b over 2a. So I need to take the opposite of -8, which is 8, and divide by 2 times my a value, which is 2. So I have 8 divided by 4, which gets me a 2. So right away I know that my vertex has an x-coordinate of 2, and I know my axis of symmetry will be the line x equals 2. To find the y-coordinate of my vertex, I have to plug that into my equation. So I have y equals 2 times my x value squared minus 8 times my x value plus 1. So I'm plugging in this x is 2 and trying to find the y that matches with it. When we're simplifying this first piece, we have to square first. So this 2 gets squared right here. My 2 is going to get squared and become a 4. 4 times 2 would be 8. -8 times 2 would be -16, and then there's a plus 1. 8 minus 16 is -8. Adding 1 gets us -7. So my y-coordinate of my vertex is -7. Let's go ahead and plot that. 2, -7 is my vertex. Since A is positive, I know that it should open up from there. So I know that I have a minimum point when y is -7. We do know already that domain is all reals, and we know that our range is going to be tied to that y coordinate of my vertex. And since my graph is going to open up from there, I should be greater than or equal to -7. Now, we need some more points before we can actually finish this graph. We know the vertex is at 2, -7. So I'm going to label that with V. My y-intercept is always going to be 0, C. So if I put 0 in here for my x's, the only thing I have left is that 1. So let's graph 0, 1. And then we need to find one more point. Since we have a value where x is 2 and we have one at 0, let's go ahead and fill in the piece in between. Let's put a 1 in there. So we're going to plug a 1 into our equation. It was 2 times our x value squared minus 8 times our x value plus 1. Substituting that, or simplifying that I should say, 1 squared is 1 times 2 is 2. We're subtracting 8 times 1, which is 8, and we're adding 1. 2 minus 8 is -6. Adding 1 gets me -5. So I know another point on my parabola would be 1, -5. And let's draw in our line of symmetry, because we're just going to mirror those 2 points across it. So this point right here is 2 spaces to the left of my line of symmetry, so I'm going to move 2 spaces to the right. This point down here is 1 space to the left, so I'm going to mirror it over 1 space to the right. And now I have my 5 points, and I can draw in my parabola. Make sure you put arrows on the end of it, and then it's a nice smooth curve. All right, we're going to try another one. This time our A value is -1, our B value is 4, and our C value is 3. So x equals, we want the opposite of B divided by 2 times A. So the opposite of B would be -4, and 2 times our A value would be 2 times -1. So our x value would be -4 divided by -2, which is 2. So I know that my x coordinate of my vertex is 2, and my axis of symmetry is also going to be x equaling 2. To find our y value, we have to plug that in. So y equals the opposite of our x value squared plus 4 times our x value plus 3. 2 squared is 4. We want it to be the opposite, so -4. 4 times 2 is 8 plus 3. -4 plus 8 is 4. 4 plus 3 gets me 7. So my y coordinate of my vertex is 7. So let's plot the point 2, 7. And because my A value was negative, I know that this is going to open down. So I should see a parabola that looks like that. That means my vertex here is going to be a maximum, and the highest value for it was 7. I'm at 7 right there. My domain is always all reals, and my range, since my y values are going to go down from there, I know that y has to be less than or equal to 7. All right, and then once again, we need to find a few more points to make our graph. We found our vertex at 2, 7. We want to find our y-intercept at 0 something. It's always going to be 0, C. And for this equation, my C value was 3. So let's plot that point, 0, 3. And let's find one more. Since we have an x value of 0 and 2, let's go in between that and put a 1. And let's plug a 1 into our equation. So y equals the opposite of x squared plus 4 times x plus 3. And we chose to plug in a 1. 1 squared is 1. This makes it a negative 1. 4 times 1 plus 3. Negative 1 plus 4 is 3, and 3 plus 3 is 6. So we are looking at the point 1, 6. Now notice that all of my points so far have been on the left of my line of symmetry. So now I'm going to mirror them over to the right side. So my point at 1, 6 is going to move to 3, 6. The point that's at 0, 3 is going to move to 4, 3. And so my two sides match, and I can draw in my parabola. All right, we have one more to try. You can go ahead and pause the video and then turn it back on when you've finished and check your work. All right, so this time around we have A being negative 2, B is negative 12, and C is negative 10. So my x-coordinate for my vertex, opposite of B over 2A, so the opposite of negative 12 would be 12. 2 times our A value, which is negative 2. That means we have 12 being divided by negative 4, which gets us negative 3. My axis of symmetry, remember, always goes through that same value. To find our y value, we are going to take this negative 3 and plug it in for our x. So y equals negative 2 times our x value squared minus 12 times our x value minus 10. We are dumping in an x value of negative 3. Negative 3 squared would be 9. 9 times negative 2 is negative 18. Negative 12 times negative 3 becomes 36. And then if we simplify that, negative 18 plus 36 is 18. Minus the 10 would get us an 8. So let's plot our vertex, negative 3, 8. Since our A value is negative, we know that our parabola should open down. That means we have a max when y is 8. Domain is all reals, but our range is going to be all the y values that are less than or equal to that highest point of 8. All right, our vertex was negative 3, 8. Our y-intercept is always going to be 0, c, and in this case, c is negative 10. So let's plot that point, 0, negative 10. My line of symmetry, I can reflect that or mirror that y-intercept across my line, and I have a point there. But I still should find one other point to kind of fill this in. So we do have some space between our 3 and 0. We could use negative 1 or negative 2. Wouldn't matter which one we plug in. If we put a negative 1 in, we had negative 2 times x squared minus 12 times x minus 10. And we're going to plug a negative 1 in there. Negative 1 squared is positive 1 times negative 2 is negative 2. Negative 12 times negative 1 is positive 12. And then we're subtracting 10. So negative 2 plus 12 would be 10. 10 minus 10 is 0. So we have the point negative 1, 0. Let's go ahead and mirror that over. Negative 1, 0 is 2 spaces from our line of symmetry, so we'll go 2 spaces on that side. And then we can connect our dots for our nice smooth parabola. All right, go ahead and work on your worksheet to practice this skill.